Hello, welcome to Natural Science 4150. This is the kind of history of science, technology, and culture. We're going to start this course online and then move to Ireland. So I've got the syllabus here that you can look over. Uh, it's got my contact information and a little bit of information about the course and the outcomes and that sort of stuff. Um, And we'll talk about this more once we start classes in Ireland. Another thing to watch is I'll send out this schedule. This is also the same schedule we use for travel writing. It just lists the topics we'll be covering. And what we're going to be doing in this class is every unit we're going to be doing a different topic. So this first unit we're starting online is all on timekeeping and navigation. And then we'll be doing different things. So for example, we might have a unit on power generation, food preservation, paper and printing, textile and clothing, medicine, things like that. So there'll be a different unit each, a different technology that we'll be looking at each week. Right now, I don't have this in Blackboard. I'm going to link to these documents that'll have you work through this, so everyone can see this. Even if you're not enrolled in the class and you're just auditing the class, you might want to just look at some of these resources, particularly once we get in Ireland and we tie guest speakers and stuff to Ireland, and then tie in some of our concepts or topics to places we will be visiting here. So the first thing I want you to do is watch this video on timekeeping. Uh, Here, it's from Ann Curtis, who's works at the National Physics Laboratory. She's a doctor at there in the UK, so it's UK based things. And since we're going to be in Ireland a lot, we'll be using a fair amount of UK resources for this. So you'll watch this activity. I will do a quick summary here. You can watch, well, you're watching my summary right now, of course. And then I want you to select one of these resources to watch, either one of these articles, one of these podcasts, or one of these videos, and watch that. And then while you're watching this, you have to do these two things. The first thing is you will do a question or quotation. So there's this document here, the question quotation document. Find an empty spot here, put your name, put your learning resource, and a question and quotation. So I just did a sample here, selected an interesting quotation and a question. And once we start class, you'll be doing this before class and bringing these questions and quotations to class there. And so again, select one of these things, and then again, select a question and a quotation from that. Question should be just as you're watching it, something you're wondering, some question you just kind of brings up, and you just provokes your thought idea. Another thing you want to do is look at a historical point in here. We want something to tie to our timeline. We'll be building a timeline throughout this unit. We're going to start with an online timeline here. And so you have this link to this spreadsheet here, and you want to do this timeline here, and we'll show you how to do that. So let's just say you are reading an article and you find out that, so let's say you're watching your movie or your podcast and you find a date like 1500 BC. Here we have simple Egyptian water clocks here. So you go to your timeline, and we'll be using BCE here. Go to about 1500 here, and we'll be wanting you to add things to this timekeeping, this green band here. So you're going to do two steps here. You're going to want to click on the blocks and type in the date 1500 water clock. as just kind of a placeholder there. So you've got a placeholder, but then you want to give a little more detail here. So if you look up here, if you go over this, you see more detail pops up, and it also records your name, and that'll be important. So here I want to insert a comment. So I want to add a comment here, and I'll say 1500 Egyptians Okay, and once you've typed that a little more detail in, as much detail as you can get from your resource, you just add that comment in here. So we'll have that. Okay, so two things you want to do is post a question and a quotation to this document and add something to the timeline here. And this will all be due by this coming Sunday, January 19th. For those of you taking the class. If you're not officially registered for the class, you certainly aren't required to do any of this material. So then a quick summary of what's going on here and highlight a couple of key points here. I want you to, hopefully you've watched this timekeeping video here, and a couple highlights here. This really focuses on the definition of what a second is and how that's changed over time. And he talks about why we have this strange definition for the second and walks us through. There's a really nice discussion here about accuracy versus precision, which I found interesting. And also just what is a clock and what does a clock do. So first thing we want to talk about is solar time and what solar time is. And we'll get into this actually more when we get into astronomy, but in early civilizations we were measuring the change of the sun throughout the year, and also the day with the sunrise and sunset. And what we'll see in some of the Neolithic and early stone circles in Ireland, we'll see a number of them are set to measure astronomical units tied to like the winter and summer solstice and stuff like that. And again, we'll get some more into that when we get into astronomy actually on site there. It's interesting to see the early clocks, these water clocks that were done, wax clocks, and how they were used. Some of them are here, but some of them. So if I jump into Wikipedia here, Wikipedia walks through some of these similar clocks. They talk about these candle clocks, which are candles with lines in them, and as the candles burn down, you can tell what time it is. Wikipedia also has some nice resources talking about, like I mentioned, the ancient civilizations and watching the sun and the moon, and how some of these stone circles, which we'll be seeing a number of them in Ireland, are used and tied into these various parts of the times. And then talks about sundials and measuring the solar time here. But much of the early timekeeping was either tied to the sun, and then often not that accurate, or like sundials or things like that, or water or things falling. You probably have all seen hourglasses and things like that. Things did not get better until we got into the use of pendulums. So while we had early geared clocks, often invented or used in China or in the Arab world, the first real, there was a significant advantage when we got to pendulums and how they were working. So Galileo in the 1500s explored pendulums, and so if you have a weight swinging on a pendulum, the time it takes to swing back and forth is dependent only on the length of the pendulum. It doesn't matter what the weight is. Here you can have a heavy weight or a light weight. It doesn't matter. All that matters is the length of the pendulum. And so by controlling that, you could control this. And Huygens turned this into a first clock in the 1650s for us. We'll talk a little bit when we get in Ireland about why telling time was important. In medieval Ireland and medieval Europe, a lot of this was driven by Catholic monks who wanted to make sure they regulated their daily prayer and work schedule, and they wanted some accurate time records for that. I think this video does an excellent job walking you through the longitude problem and explaining that. And that's one of the reasons why we tie navigation into this area, is that accurate time keeping was very important to solve this longitude problem. And there was a prize given out to even to solve this, so you can look at the longitude actor prize that was developed. One thing that's not mentioned in this video is railway time, which came a little later. But one of the once we had accurate times, all of a sudden people realized that every community had their own time, and that wasn't a problem as long as you were walking or taking a horse from one town to the other. It might take you a day to get to the next town, and so if the next town over was 25 minutes different in time, that didn't matter, because you would just check their clocks as you got there. I remember I went to a college where the bells rang every 15 minutes. An hour bell rang for tolling hours, and then every 15 minutes the bell rang just once or twice, and you could, or three times, depending on if it was 15 minutes, 30 minutes, or 45 minutes, half the hour. So I remember being out fishing on the lake and hearing the bells ring and having to realize, oh, I better get in and get to class. And that was fine, often for monks and for different areas that, you got to a different place and it had different time. But when the railroads started going across England and then certainly across the US, we got to see issues with the times, and the trains had their own clocks and stuff, and so there was a lot of work on standardizing times and time zones with the railroads. And so that transportation issue really pushed standardization of time and time zones, and make sure that everyone was on the same time in one area of the United States. So with the pendulum clock and time zones, we are able to define a second in terms of a portion of a day, what's called a solar day. But there were problems with this. All days were not always the same. Days vary over time. So as clocks got more accurate, this became an issue. In the 50s and 60s, we developed atomic time with the cesium clock and how that worked. And again, this is a physics professor talking here, and so gives a good description of the state of cesium and how it would change from a ground to excited state and how that's used to tell time. You certainly don't need to know all of this, but it is an interesting view, and I think it explained quite well in this video how atomic clocks work. But atomic clocks are very accurate, and that leads to our last point related to navigation, and that's the GPS system. One thing accurate clocks do allow us to do is set up with GPS systems. We can have atomic clocks in satellites and orbits, and then we can use, they can be sending time signals down to Earth, and then we can use that to tell specific locations in three-dimensional space. And again, this walks you through a little bit on how that works using this, what's called time of arrival ranging, which is what GPS systems do. So we'll be hopefully you'll find an interesting resource you want to read to learn a little bit more about time travel, timekeeping. Select one of these resources, and again do a quotation question and then a historic point to